Hi, welcome back to the channel. So let's now get to look at IVPs. We look at question 3 of this worksheet right here. Okay, so which says use Euler's method to approximate the solution to each of the following IVPs. Okay, so I'm going to begin with question 3a. Okay, so one thing you need to understand about IVPs is that uh, like if you're using Euler's to approximate, um, it's in the sense where let's say you're given an IVP, an initial value problem. Let's say dy dt equals to f of t y. Okay, so you have the interval um, where you have your t between a and b. Okay, then y of a, that's more like your initial point a, is equals to some value alpha. Okay, so another information that we need to keep in mind is that to simplify work is the fact that w naught is equals to alpha. That is when you're not given the value of w, and you need to take note to say in some textbooks they don't use w but they use y, so that would be like y naught is equals to alpha. Okay, so what other piece of information do you need to get? Okay, so one assumption that we make um, about all of this is that you're trying to find the approximation of y at various points that are called mesh points. Okay, that are called mesh points. So I'm trying to simplify this as much as I can. So you're trying to approximate the value of y at points called mesh points. Okay, so that is within this interval that you have here, a comma b. Okay, so having done that, you're going to make an assumption to say that those mesh points are equally or evenly distributed, such that we're going to use the letter t. Okay, we're going to use the letter t sub I being equals to a, which is your first point, plus I times h. Usually the value of h you are given in a question. If you're not given, this is how you can determine the value of h. Okay, so once again, it's either they use this notation, or another notation that you can use is t sub n is equals to a plus nh. Okay, so either this one or this one, it simply means the same thing. And we can also add a condition to say your I, okay, or your n, depending on what you use, is equals to, you start from 0, 1, 2, um, all the way to n. Okay, so I talked about a situation where you're not given the value of h. How do you get to determine the value of h? If you're not given the value of h, it basically means the value of n you are given. Okay, so what the value of n talks about basically is the number of steps that you're going to take for you to reach at the final approximation that you're looking for. So your h is equals to b minus a divided by n. So it simply means if you don't have the value of h and you have the value of n, you can basically come up with your value of h because you need it. So the expression, okay, or Euler's method that we're going to be using to make these approximations, we're going to say wi plus 1, but allow me to use n. Okay, you can use I or n, doesn't really matter, just like I illustrated at this point as well as on this one here. Okay, so I'll say wn plus 1 is equals to wn, which is what we have right here, but sometimes that is like for the first point, uh, because initially if you want to determine what w1 is, it simply means your n is supposed to be 0, because observe this, you are starting from n is equals to 0. So it simply means you're going to say your w0 is equals to alpha. Okay, so sometimes you're given what your w is. If you're not given, just make sure to say, you remember to say your w naught is equals to your y of a is equals to alpha. Okay, so that's one thing that you have to keep in mind right here. Okay, so this is going to be, we say plus, you're going to have h here. So that is why I was trying to emphasize why you need the value of h. Okay, there. Then that would be f of, I'll say t sub n, comma, t sub n, comma, w sub n there, like that. So this is Euler's method. That's what you're going to be using. So you find that in some textbooks they use wi plus 1 is equals to wi plus h by f of ti, comma, wi there, like that. Okay, so whether you use this or use that doesn't really um, change anything. So allow me to use n in this case. Okay, so what other piece of information do we need? Perhaps we can go to, we look at one of the questions. So let's look at question 3a. Okay, so question 3a, we are given y prime. We are trying to use Euler's method to approximate the solution to y prime is equals to 1 plus, open bracket, t minus y, close bracket. Then you have squared there. Then the interval is from 2 to 3 of t. Then you're also given this initial condition here. Then you're also given the value of h, so you don't really need to worry about the value of h because already given. Okay, so if you look at b, we don't have a value of h, but we have been given the value of n, so it looks like we'll be able to find the value of the value of h there. Okay, so we are given this derivative. Okay, this differential equation, y prime is equals to 1 plus t minus y squared. So the interval that we have is 2, okay, to 3. So keep in mind to say this is your a and this is your b. Okay, then the initial condition y of 2 is equals to 1. Then h is equals to 0.25 there, like that. We already given, so you don't really have to worry about our value of h there. Okay, so there is the first question when it comes to solving these is that how many steps do you take, okay, before you could come up with a conclusion to say, okay, this is now the final approximation, because you can continue iterating as much as you can, but there's always that point, like there's always a part that tells you how many steps that you have to take. Okay, so what happens here is that remember, we're talking about n starting from 0, 1, 2, going all the way to what, to n. So I would want to know what n is. Okay, so remember we said h is equals to b minus a divided by n. This tells me that n is equals to b minus a divided by h. Okay, so what is our b in this case? Our b is a 3 minus a, which is a 2, divided by h, which is 0.25, is equals to that would be equals to a 4. So n is equals to 4. So this tells me to say I'm taking 4 steps for me to reach at the final approximation. Okay, 4 steps. And keep in mind, you are starting from n is equals to 0. So it simply means you start from n is equals to 0, n is equals to 1, n is equals to 2, n is equals to 3. All of these, when you add them together, they give you 4 steps. It doesn't mean you need to go up to n is equals to 4. This will mean your n is equals to what? N is equals to 5. 5 steps, like 1, 2, 3, 4, 5. But because n is equals to 4, it simply means you are ending at n is equals to 3. So there are 2 approaches that you can use to this to answer such questions. Okay, I'm going to start with the first one, then I'll go to the second approach. I'll use the same question. Okay, so the first approach is the fact that I know to say the solution that I'm looking for. Okay, I've said this wn plus 1 is equals to wn plus h, then you have f of t sub n comma wn. So keep in mind, I said this can also be written as y sub n plus 1 is equals to y sub n plus that then you have f of t sub n comma y sub n. It's just one and the same thing. Okay, it's just one and the same thing there. So what you're going to do here is that allow me to use this one for now. Oh yeah, allow me to use this one. Doesn't really matter, it's the same thing. So I can just get rid of this part so that we don't confuse ourselves. So here I'm going to begin with the first step. The first step is when n is equals to 0. Remember, we are taking 4 steps, so we'll move from n is equals to 0 to n is equals to 3. So if n is equals to 0, what I'm going to do, or maybe even before I do that, since I'm using the first approach, is I'll try to come up with the generalized expression. Okay, you'll see in a short while why I'm calling it a generalized expression. So I'm looking for, I'll say wn plus 1 is equals to wn the way it is plus my h. H we have been given as 0.25. Okay, then f of, what is our t sub n? We haven't yet determined what our t sub n is, and let's do that. So t sub n is equals to a plus nh, like that. So t sub n is equals to, what is your a? Your a is a 2 plus, what is your h? 0.25. Then you put your n there. Okay, so that is what our t sub n is. So t sub n is equals to, we say, is 2 plus 0.25 n, like that. So that's what I place here. That would be 2 plus 0.25 n comma just wn the way it is. So this right here, you have to place it or substitute it in this one here. Why are we doing so? We know that y prime is simply equals to f of t comma y, and in this case our y is represented by this, then our t is represented by that part there. Okay, so it simply means we have to come and say wn plus, I'll say 0.25, then f of, or maybe I don't really have to do that, I can do the substitution. So it simply means in this differential equation here, okay, you're going to say 1 plus, in the brackets where there is t, you substitute with this portion here. That will be 2 plus 0.25n, okay, minus y. What is our y? It's wn, like this. Okay, so it simply means the generalized expression wn plus 1 is simply equals to, I'll just say wn here plus, I can expand this, 0.25 plus 0.25 open bracket 2 plus 0.25n minus wn squared, and that happens to be my generalized expression, and it's the one that I'm going to be using. So this one here is our generalized expression. So remember, this is the first approach that I'm taking. So now let's go ahead and start approximating this. So we'll start from n is equals to 0. When n is equals to 0, it simply means when you plug in 0 here, this is going to be w1. Okay, so that would be w1 is equals to w naught. Why? Because like that would be like w0, but we know what w0 is. W0 is equals to the initial the result of the initial point, like the one that we already given. So that is what? It's a 1. We are given a 1. Okay, then I'll say plus 0.25 plus 0.25, then here I'll say 2, this is a plus by the way, 2 plus 0.25 times 0 minus wn, or not in this case, since n is equals to 0, is a 1, then squared. If you punch that on your calculator, that's going to give you 1.5. Okay, let's go to n is equals to 1, so meaning this is going to be w2, so that will be equals to here you're going to have w1 because n is equals to 1. And but what is your w1? Your w1 we have determined that is equals to 1.5. Let me say plus 0.25 plus 0.25 open bracket 2 plus 0.25 0.25. Where there's n, we plug in 1, it's just 0.25 minus Wn, which is 1.5 squared, is equals to, punch that on your calculator, you're going to end up with 1.80625. Okay, then n is equals to, remember we're going up to n is equals to 3. Now n is equals to 2, it will give us W3. Okay, W3 is equals to, so here once again you're going to say W2 because your n is equals to 2 now, as I have indicated here. Okay, so what is your W2? We have already calculated, it's 1.89065 plus 0.25 plus 0.25, then here we have 2 plus 0.25 multiplied by 2 because your n is a 2, okay, minus 1.89065 squared, and doing that on your calculator, you're going to end up with something like 2.233459473. Okay, let's go to our last iteration. So that would be our n is equals to 3. So meaning our W4 is going to be equals to, and by the way, all of these like W1, 2, 3, 4, I'm just getting them from here. I'm just substituting where there's n here. I put what n is equals to, then that's what we get. So here once again we're going to have W3, okay, because n is equals to what? N is equals to 3. But we already calculated W3 rather, which is 2.233459473 plus 0.25 plus 0.25, in the brackets we put 2 plus 0.25 times 3 minus 2.334, wait, I've missed a number, 2.233459,473, and when that is squared, punch all of this on your calculator, you're going to end up with something like 2.550163002. Okay, so this happens to be our last iteration, okay, or our final approximation, and this is the answer that you're looking for. So let's try to save this answer somewhere so that at least we'll be able to compare when we use the other method. So the answer that we have gotten is, we are going as far as, look at this point, the highest we are going is 3, so meaning y of 3 is equals to the same 2.550 and there's 002 somewhere there. So that's what we have gotten by us using this like generalized expression that we have come up with. Okay, so now let's go ahead and do this in a different way. Okay, so let's go ahead and do this in a different way, or maybe a way that you might perhaps be familiar with. Okay, but I find this way much convenient for me. I just find it simply means I have to do the substitution only once in the main equation, then the rest is just a matter of substituting in the generalized expression, as I'm calling it. Okay, so the other method is you taking everything step by step. So what I mean by step by step is that first things first, you have to consider the fact that since you are given t sub n to be equals to 2 plus 0.25 n. Let me find all the t's, because I know to say I'm going as far as I'm going as far as what? As 3, and I know to say my n is equals to 3. I mean 4 rather. So it simply means I'm taking 4 steps. Okay, so what this information does for me is the fact that I'll start from t naught. T naught is going to be equals to 2. Why so? Because you plug in 0 here, you're going to get 0 there. So then t sub 1 will be equals to if you plug in 1 there, that would be 0.25 times 1 is 0.25 plus 2, that would be 2.25. Then t sub 2, that is the third step, so one more remaining. So 0.25 times 2 is 0.5 plus 2, that would be 2.5. Then t3, which is our last one, that is going to go to 0.25 times 3 is 0.75 plus 2, that would be 2.75. So we have the information that we need. So t naught is equals to 2, then t sub 1 is equals to 2.25, then t sub 2 is equals to 2.5, then t sub 3 is equals to 2.75. If you observe in the previous one, in the previous method, I didn't really have to come up with all these. Okay, so let's go ahead and work this out. So for the first step, okay, I'm going to call it step 0. Okay, allow me to call it step 0. So under step 0, one thing you know is that you're going to have t naught, which is equals to 2. Then you're also going to have w naught, which you already know to say is equals to what? It's equals to 1. So it says equals to 1 there. Okay, so the first thing that you do is substitute in the main equation. So it simply means you're going to say f of t naught comma w naught is going to be equals to f of your t naught is 2, w naught is 1, is equals to, so that would be 1 plus you say 2 minus 1 squared, because where there is t here, substitute with 2. Where there is w, you substitute with, sorry, where there is y, you substitute with w, which is a 1. Okay, so this is going to end up to give you something that is a 2. Okay, so this is not all. So now that's when you can get back to, because for the step 0, it simply means your n is equals to 0, right? So it simply means this is going to be w1 is equals to w naught, you already have in the equation, is what? Is 1 plus h is 0.25 multiplied by this here we have already evaluated, is this part here. Okay, and this equals to what? Is equals to 2, and you're going to end up with 1.5. 0.25 times 2 is 0.5 plus 1 is 1.5. So you go to what? You go to step 1. Okay, step 1, meaning you're going to have t sub 1. T sub 1 is what? 2.25. Then you're also going to have w1. Your w1 is 1.5. Okay, it's 1.5. Then first things first, once again, you're going to have f of t sub 1 comma w1, which is equals to f of t sub 1 is 2.25 comma w1, which is 1.5, and this will be equals to 1 minus, or rather 1 plus t, which is 2.5, sorry, 2.25, 2.25 minus 1.5 squared, and you're going to end up with 1.5625, something like that. Then you go ahead and find your w2. Why is it w2? It's simply because for step 1, n is equals to 1. So when you plug in a 1 here, to be 1 plus 1, that would be a 2. So that is w sub 2, or w2. And that would be equals to, this would be equals to w1. Why w1? Because we know from the equation, because our n is equals to 1. So our w1 we already calculated is what? Is 1.5 plus our h, which is 0.25 multiplied by 1.5625 and this is going to give you something like 1.890625. I believe this appears to be familiar, so I'm going to have to erase these initial steps, because yeah. So we are now going to step 2. We are from step 1. So for step 2, we know that we are going to be using t sub 2, which is 2.5, then and w2, which we have calculated as 1.890625, like that. So it simply means here, once again, all we have to do is to say f of t2 comma w2, it will be equals to f of t2 is 2.5 minus, sorry, comma 1.890625 is equals to, it used to be 1 plus open bracket your t, which is 2.5, minus 1.890625, and this is going to end up to give you something like 1.37133791. So remember, step 2, it gives us w at w3. Why? Because n is equals to 2, you plug into there, you get a 3. So this is going to be something like, you're going to start with w at wn. What is your n? Your n is a 2, so that would be a 2. So w2 we have already calculated is 1.890625 plus 0.25, which is our h, multiplied by our f of t2 w2, which is 1.371337891. So that is equals to w3. If you punch on your calculator, it will be 2.2334 or 59473. Okay, so let's go to the last one, which is step what? Step 3. That will give us our final approximation. So our step 3, you have your t3 which is equals to 2.75. Then your w3 we have calculated to be 2. So make sure you say you calculate the correct things, because each step that follows is dependent on the previous one. So we have 2.2334599473. What is this? So this right here, we can say f of t3 comma w3, it will be equals to. So once again, it's more like f of 2.75 comma 2.233459473, which is equals to, you say 1 plus 2.5 minus 2.233459473 squared, and this, if you punch on your calculator, that's going to give you something 1.2668 14116. So meaning the final approximation, which is w4, okay, w4, which can also be in terms of y, is like y of 3, is equals to w3. So we are going to, like, we are looking for w4 to be equals to w3, which we have calculated to be 2.233459473. Then that will be plus your h, which is 0.25, multiplied by your function, like this that we have substituted here, and we have ended up with 1.266681416, giving us something like 2.550163002. which is the answer, and it's the same as what we got earlier. So the thing is that even if you use the earlier method where I first of all I come up with the generalized expression, then I just start substituting the value of n and the value of w as you are progressing, or you use this method where you have to get back to the initial function every time, is basically up to you. Okay, it depends on which method you see is faster for you, because obviously during an assessment you need to be as fast as possible. These questions are very simple. It's just a matter of you being able to do the right computations and doing them efficiently and in the quickest time possible. So between method 1 and method 2, let me know in the comment section which one you think is cool with you. Okay, so that even as I'll be doing the other questions, I'll try to pick the best and quickest method. So that will be all in this video. We'll look at question B and C in a separate video. So thank you very much for watching, and to catch you in the next one.